So what we were just emailing about, if you are taking the derivative with respect to time, and in the example we had, this was h, because these don't match, that's when you would call it dh dt. Because in this case, h is a function of time. So it's like, I'm just making this up, but something like that, where the derivative of t would be 1, but the derivative of h is going to be this whole formula for whatever that derivative is using the quotient rule. But h is a function, it's not an independent variable. So I think this shows that the derivative of t is 1 because it's the independent variable, but the derivative of h is going to be a whole involved formula. But very easily said, if these don't match, that's when you need implicit differentiation. So if you were differentiating with respect to time, the derivative of t is 1. If you were doing d dx, differentiating with respect to x, and it was 3x, then the derivative is 3. But if you have the derivative with respect to x and you're doing the derivative of 3y, then 3 is a constant you can move over, but the derivative of y is not 1 because your independent variable is x. So then you would have dy dx. Sorry, my handwriting. All right, so hopefully that is a little bit helpful. And then this was the last question you asked. I'm laughing because we spent a lot of time talking about this in our training. So you were asking about the second derivative at 3, and you have the first derivative, and then you know it doesn't exist because it's a corner. So that year, this is 2017, they did accept, kids wrote, it's a corner, so the derivative doesn't exist. It's a pointy place, so the derivative doesn't exist. They did end up accepting that as an answer. And I understand why you're saying that, because I did not talk about left and right hand derivatives very often at all. But I think the gold standard response is to talk about the left-hand derivative does not equal the right-hand derivative. So if you're taking the derivative here, or the slope of the tangent line is just going to be the slope of that line. So the, oh my gosh, did they use limit notation? That is so ugly. They're doing like the definition of derivative there, like the alternate definition of derivative. Yeah, I wouldn't worry about that. I would say if you want to write, here's like a middle ground answer. Definitely you can write the thing about the corner for sure, and I think that would give you your credit. You can also say the left-hand derivative at, or no, it's not even at, it's not the derivative at 3, but because it doesn't, the derivative does not exist at 3. The left-hand derivative as x approaches 3 from the smaller numbers is, and it would be the slope of that tangent line. So what is that doing? It's going up 2 and over 1. I want to say, yeah. So that's 2. And then you could say the right-hand derivative as x approaches 3 from the bigger numbers is, and that's going to be the slope of that tangent line. And what is that doing? That's going down 2 and over 2. So I want to say that's 1. And then you can write something about how the left-hand derivative does not equal the right-hand derivative. So f double prime of 3 does not exist. If you're looking for a little bit more than just saying it's a corner, and I want to look at this again. Did I get those numbers right? I sure didn't. I was close. -1, because it's going down and over. Okay,